Hello everyone, welcome back to my channel. In this new video we are going to look at the solution to question 5. So the question goes, show that the transformation T mapping R2 to R given by T of xy equal to 3x minus y. So we are going to show that this transformation is a linear transformation, and we are going to find its matrix representation. So be with me as I take you through the solution to this question. So first let's have what we need here. So we need T of xy equal to 3x minus y, and we are going to show that it is what? A linear transformation. Let's open our notebook. So first we should know the conditions for linearity of a matrix transformation. Let me cancel it. I've said it. So let's look at the conditions. So there are two key conditions surrounding a matrix transformation. One of them is that the transformation of u plus v, where u and v are two different vectors, so is equal to the transformation of u plus the transformation of v. So if this is true, if we perform this operation on our matrix transformation and we see that transformation of u plus v gives us transformation of u plus transformation of v, then we can say that okay, it has met one of the conditions. Then we proceed to perform the final key transformation condition, linear transformation condition, which is what? Ku, where k is a constant. So let me represent this as vectors. So where k is a constant, is the same as what? K multiplying the transformation of the vector u. So this is the second main condition for linearity of a matrix transformation. But let me give you the minor one. The minor one is that whenever you are given a transformation, to check whether it is a linear transformation, substitute the zero vector into the transformation to see whether it will be the same as what? The zero vector. So transformation of the zero vector should be the same as what? The zero vector. If this condition is not true, then the transformation in question is not a linear transformation. So let's perform the third one. I call it the minor condition. So let's perform the minor condition first. Let's test it to see whether our matrix, our transformation in question, meets this condition. So the zero vector, so the transformation of 0 0 is equal to, so here our x is 0, so 3 multiplying 0 plus minus y, and our y is also 0, so minus 0. So this gives us what? 3 multiplying 0 is 0 minus 0, and this is the same as 0. So we know that a transformation of what? The 0 vector gives us the 0 vector. Okay, so it has met this condition, so let's wipe it out and work on the key transformation conditions of linear transformation. So first, let u, the vector u, is equal to u1 u2, and the vector v is equal to v1 v2. So the first condition implies transformation of the vector u plus the vector v is equal to what? Transformation of our vector u is what? Our vector u is u1 u2 plus our vector v, which is v1 v2, and this is equal to what? Transformation of, so we are adding u1 and v1, u1 plus v1, and then u2 plus v2, and transformation of this. Now this is our what? X, and this is our y. So we have our x and y. We can now we know that the transformation of x and y is what? 3x minus y. So let's perform that operation. So let me do it here. Let me see whether it will enter here. So transformation of our u1 plus v1 u2 plus v2 will give us what? 3 multiplying, so let me just make more space. So note the conditions. So we are dealing with the first condition. So our u1, so our x is now what? u1. So this is our x, and this is our y. The bottom guy is our y. So x, this is now representing x, and u2 plus v2 is now representing y. Okay. So in place of our x, we have u1 plus v1 minus in place of our y, we now have what? u2 plus v2, and this will be equal to what? 3u1 plus 3v1 minus u2 minus v2. This will lead us to 3u1, we can group the u's, minus u2 plus 3v1 minus v2. So we now have this. But remember that if we were to perform the operation, transformation of u, the vector u, we will go to transformation of u1 u2. Now our x is u1 and our y is what? u2. So we'll have what? 3u1 minus what? So 3x minus y. So in place of our y, we now have u2. So you see that this 3u1 minus u2 is actually what? It's actually transformation of u, the vector u. And similarly, this one will also be the transformation of what? The vector v. So we have shown that the transformation of the vector u plus the vector v is the same as what? Transformation of the vector u plus transformation of the vector v. So our first condition is met. Okay, so since the first condition has been met, we will now look at the second condition, the second key condition, which we stated as, so I'm writing it here. So transformation of ku, where u is a vector, is equal to k multiplying the transformation of what? U. So let's deal with this. Let's see whether this condition 2 will be met. So I'm wiping out the mod to carve out space for myself. So now we know that our u is now what? u1, u2. So transformation of k multiplying u1, u2 will be equal to transformation of what? ku1, ku2, and this will give us now our x is now ku1, so 3 multiplying. So if we come back to this guy, this is the definition of the transformation. It's 3x minus y. So in place of our x we have what? ku1 minus, in place of our y we have what? ku2. This means that our transformation, so let me just write the answer. So without repeating the transformation, so this is what we are finding. So this is equal to, so we have 3ku1 minus ku2. You can see that k is common. We factor out the k, leaving what? 3u1 minus u2, and this 3u1 minus u2 is the same as we've seen from the top, as we've seen from here. T of u, the vector u, is equal to T of, we represented the vector u by u1 and u2, so T of u1 u2, which is equal to 3u1 minus u2. So we know that 3u1 minus u2 is what? Is the same as transformation of u1 u2. So it's the same as transformation of what? Sorry, I forgot about the key. So k multiplying the transformation of u, the vector u, because 3u1 minus u2 is the same as what? Is the same as the transformation of the vector u. And now we have it as, so transformation of k multiplying the vector u. So that you can conclude by saying that transformation of k multiplying the vector u is in fact k multiplying the transformation of u. So now the second condition 2 has been met. So we can say that since the matrix given to us in the question met all the what? Conditions, the key conditions of linearity, that's matrix transformation linearity, or linearity of a matrix transformation, then we can firmly state that the matrix in question is what? A linear transformation matrix. Okay, so we've done with the what? With the first part of the question. Let's visit the question once again to see what we are asked to find further. Let me close the solution now. So the question is in two folds. So show that the transformation, this transformation is a linear transformation, and find its matrix representation. So now we are left to find what? The matrix transformation. So let's do that quickly. So we are done with the first part of the question. Let me wipe that part out. So I've wiped out the first solution. Let's look at the final solution to the question. So we have the transformation of xy is equal to 3x minus y, and this 3x minus y is, in fact, we can write it as the matrix 3 negative 1 multiplying xy. So the transformation becomes transformation of xy is equal to 3 negative 1 multiplying xy. So if we perform this operation, 3 times x, 3x minus 1 times y, y. So we are just manipulating it to what? To find what we are asked to find. So if you compare xy, we'll deal with xy. So by comparison, xy and xy, also our transformation is what? The matrix 3 negative 1. So this is the transformation. Or you can also use the transformation of, so x is 1 0. So and the transformation of y, and the transformation of y is what? Is transformation of 0 1. You can also do it this way. So in place of x, we have put, so we perform the transformation. By definition, transformation of xy is this. So we have transformation of 1 0. So our x is 3 1 minus 0. So 3 1 minus 0, and then here we have 3 multiplying our x 0 minus our y is 1. So we will see that 3 times 1 is 3 minus 0 is just 3, and 3 times 0 is 0 minus 1 is also negative 1, and you will see that there's no difference between what? The two answers. So this is our what? Transformation. And now we can say that we've answered the full question. So we are through with, which question is that? We are through with that question. Is it question 5 or question 6? Is it question 5? So we are through with question 5. So in the next video, we'll be looking at the solution to question 6. See you in the next video. If you haven't subscribed to the channel, please consider subscribing to the channel. And this is second semester courses that we are solving. So if you are a level 100 doing mathematics, don't worry, this course is for you. And if you are reciting the course, these solutions or past questions, solutions to the past question will be of help to you. Thank you very much for your time once again. Have a nice time.